In today's lesson, we're going to talk a bit about some vocabulary review, as well as review some of the properties that we've previously learned in math and actually use every day. We just don't know it. So the first one is the commutative property. Remember, when you have the commutative property, you move the numbers, and then you get the same answer. So here it says the commutative property states that the order in which the numbers are added or multiplied does not change the sum or product. So in this example, a plus b is the same as b plus a. Or if you look at it in number sense, you have 6 plus 1 gives you 7, which is the same as 1 plus 6. You moved the numbers, but the answer stayed the same. It also works for multiplication. So if we have 7 times 3, which is 21, you get the same thing when you take 3 times 7. You just moved the numbers. The next property that we have is the associative property. So this one is a little bit different. The associative property states that the way in which the numbers are grouped when they are added or multiplied does not change the sum or product. So again, we're not changing our answer when we do these, but we're regrouping them. So you see up here with our letters, we start out with b plus c in parentheses, but when we regroup it, we have a plus b. If you look at it in terms of numbers, if we take 3 plus 8, that's 11, and then add 2, we get 13. Now if we regroup them and we add 2 plus 3, we get 5, and then you add 8, you still get 13. We regrouped the numbers, the order stayed the same, but we got the same answer as well. It also works for multiplication. So here we have 4 times 5, which is 20, and then you multiply it times 3 to get 60. On this side, we regrouped them, and we have 3 times 4, which is 12, and you multiply by 5 to get 60. Again, you get the same answer, we just regrouped the numbers. All right, so let's look at an example. So it says, name the property shown by the statement. So you have 2 times, parentheses, 5 times n, is the same as 2 times 5 times n. So if you look at what changed from this side to this side, you can see that the grouping, or the parentheses, changed. The order is the same. My 2 comes first, my 5 comes next, and then my n, but the parentheses change the grouping. So this would be the associative property. If you look at another one, we have name the property 3 times m times 2, or 2 times 3 times n. This time, if we look at the grouping, it actually stayed the same. We have 3 times m in parentheses there, and we also have 3 times m in parentheses there. However, my 2 no longer comes first. And since we're multiplying, this will work, and we will get the commutative property because we moved the numbers. Commutative, we move the numbers. All right, in the next example, we're actually asked not to define the property, but to say if the statement is true or false, and if it's false, you have to provide a counterexample. A counterexample is an example that shows that a conjecture is false, or in other words, the property does not apply. So this time would mean that it doesn't work. So the division of whole numbers is commutative. Commutative means that you can move numbers and you'll get the same answer. So if we have something like 15 divided by 3, because these are whole numbers, you get an answer of 5. Does that hold true if I move the numbers and do 3 divided by 15? If you type in your calculator 3 divided by 15, you get the decimal 2/10. 5 is not the same as 2/10. Therefore, it is false. The division of whole numbers is not commutative. Okay, and then this right here is my counterexample. I proved that it does not work. State whether the following conjecture is true or false. If false, provide a counterexample. The subtraction of whole numbers is associative. Okay, so associative means to regroup. So if I start off with a subtraction problem of 10 minus 2 in parentheses, and then I subtract 5, is that going to give me the same as if I take 10 minus parentheses 2 minus 5? On this side, 10 minus 2 is 8. Then I subtract 5 to get 3. On this side, I do parentheses first. 2 minus 5 is negative 3. And I have 10 minus a negative 3. When you have two negatives right next to each other, you can turn them into a smiley face because subtracting negatives is the same as adding positives. So now I have 10 plus 3, which gives me 13. 3 does not equal 13. Therefore, this is false. Subtraction of whole numbers is not associative. And this is my counter example because it does not work. All right, moving on to example 3. So Elena wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and t-shirts that cost $16. Use mental math to find the total cost before tax. So I'm figuring out the total, so I would want to add them all together. So 38 plus 14 plus 22 plus 16. Okay, now yes, I know that you guys can add them, but they asked us to use mental math. So if we were trying to figure out and make easy math that we could do inside our head, which ones do you think we would regroup so that we could add them more quickly? I would probably regroup 38 plus 22 and then add it to 14 plus 16 because I know that 8 and 2 will give me a perfect 10. So then I would have 40 plus 20, which is 50. And then over here, I know that 4 and 6 make a perfect 10, so then I would have 20 plus 10, which would give me 30. So 50 plus 30 would give me a total cost of $80. Okay, again, we could check our math if we actually wanted to do this out. So I would make those to get a perfect 10. So then I would add 2 to this side, in other words. 2 plus 3 is 5, 6, 7, 8, 9. It looks like I did my mental math wrong. You guys probably already found the mistake I made. And instead of getting 60, I did 38 plus 22 and got 50, so that was the mistake I made. You should get the answer of 90. It's always good to check your work like I did so that I get the right answer. All right, let's see another one since I messed that one up. In a garden, a decorative pool in the shape of a box is 2 feet deep, 17 feet long, and 15 feet wide. Use mental math to find the volume of the water in the pool. Okay, well we know that volume, if you look at your reference sheet, is base times height again, because this is the square, or this is the area, and then you take the area times the height. So we have 2 times 17 times 5. We can do in our head 2 times 5, which gives me 10, times 17 to get an answer of 170. So pairing together to make it easier on yourself. All right, and I have 2 more examples for you, and then I'll be done. So example 4, we need to simplify 7 plus g plus 5. All right, so in this one, we can't just add 7 plus g because we don't know what g is. But is there something that are similar that we could combine together? We could combine 7 and 5 because we know what 7 plus 5 is. 7 plus 5 is 12, and then you add g. That's all that we can do because we don't know what g is. So you just have 12 plus g. And my last example, we have to simplify again. On this one, we have m times n. So if I have m times m, I have m squared, just like 2 times 2 is 2 squared, times 11. Since it's multiplication, you can actually multiply these together to get 11m squared. This would be our simplified answer.